Hey everyone, we're solving this physics paper 5 today. This is 9702, paper 5-2, major in 2022. I know you have an exam tomorrow, so good luck with that. This paper also has a tricky question too, quite similar to paper 5-1, the one I posted a few days back. So you should be careful with that. I'm gonna explain that again in this video. So let's take a look at the threshold. So for paper 5-2, this is what it looked like. Um, out of 30 marks, A was at 20, B was at 17, C was at 14, D was at 11, and E was at 8. So U is probably at around 4 and A star is probably at around 23 to 25 approx. Okay, approx. We don't know for sure. But it's around 23 to 25 if you want an A star. Okay, that isn't usually shown in the threshold, but the combined one is shown down below. All right, so let's begin. Starting with question number 1, we have two parallel cylindrical conductors. Each have a small cross-section area A. A thin metal bar connects the two conductors as shown in figure 1.1. Okay, so the metal bar has a square cross section with sides of length y, right? And for each conductor, the distance between its end C and the center of the metal bar is L. Okay, so this is the distance L that they're talking about. This is the distance from the end C to the center of the metal bar. Great. So the distance between the centers of the conductors, this distance, the center of the conductor C is x actually. The ends are connected to a power supply, great, and the current I in the conductors is measured. It is suggested that I is related to L by this relationship. Okay, great. Where E is the electromotive force EMF of the power supply and P and Q are constants. Plan a laboratory experiment to test the relationship between I and L. So basically what you guys need to understand is that the first part is identifying the problem, the second part is methods of data collection, the third part is additional details, and the fourth and final part is analysis. So you have to start with identifying the problem, and then the order doesn't really matter, although it's suggested that you go for methods of data collection and additional details first, followed by analysis. Okay, so let's begin. So the relationship needs to be between I and L. They have told you that already. Now you have to think about this in a chronological order, like which one will be the independent variable. Basically, something that you determine initially before the start of the experiment is the independent variable. Like, for example, think about current and length. We are going to measure current afterwards, right? It isn't like we're going to set current followed by measuring the length, right? That doesn't work out chronologically. We are going to set the length L first, right? We're going to set the length L first and then measure the current using what exactly? An ammeter. Hopefully I could clarify. Okay, so clearly our independent variable is L and I is the dependent variable. You could also word it like this. You could say vary L and measure I. That works as well. And that's the first mark from identifying the problem. Now we have to go to the second mark, okay, which is identifying the control variable, something that has to be kept constant throughout the whole experiment. And remember, when you're performing an experiment, you're testing the relationship between two things, current and length here. So if you do not standardize the other things, this is more important for biology rather than physics, but still, if you don't standardize the other things, your experiment won't be valid. Everything else except these two things have to be constant, since these two are the only variables you're dealing with. Understood? So let's think about things that could be kept constant. Typically, listen, typically the thing that you need to keep constant should be present in this equation. I'll teach you a few more tricks. Check this. So obviously it's not going to be I or L, since these are, variables, so they're not going to be control variables. Next, sorry, the control variable, yeah, the control essentially, and it can't be 2 because 2 is a constant. So it's between E, P, A, Q, X, and Y squared. Now I'm going to teach you more tricks, okay? At the end, they're going to say, explain how the results could be used to determine values for P and Q. This will always be present in any of your questions. You will always find this, okay? So it won't be these two. There might be one given at the end or two. Here there are two values given, P and Q. It will never be these, okay? So it's not P or Q either. So it's between E, A, X, and Y square for sure. Now, if you're unsure, why don't you just write that keep all of them constant? That's the safest bet. It doesn't have to be like that. Like it doesn't have to be like this. Suppose you don't have to say that E is the thing that needs to be kept constant or E is the control variable. You don't word it like this. Just say that if you're unsure, say that the EMF must be constant for each experiment. The cross section area must be kept constant. The distance x must be kept constant, and y square must be kept constant. For example, you'll get full marks. So like they don't have to be in any order, by the way. And even if you do write it at the beginning, for example, in this experiment, E was the control variable, but as additional details, there were other details like keep a and y constant, keep x constant. These were also 2 points in additional details. So you also get marks for those. Okay. So that's really great. That's really great. So we just scored 3 marks by saying all that. Could I clarify? That's how you get marks. This is how you identify the equation. So I'm going to tell you about the mark distribution. In identifying the problem, I already talked about this in my February March 2022 paper 5.2 video, but I'm going to talk about it again. It's fine. Identifying the problem, you are going to get a maximum of 2 marks. In methods of data collection, you are going to get 4 marks, where 1 is part of the diagram. In analysis, you are going to get 3 marks, okay? And in additional details, okay, you can get a maximum of 3 marks, although listen, there are 10 marking points. Basically there are more marking points than the marks available, and this is only present in additional details, nowhere else. Okay, so 2 plus 4 6, 6 plus 6 12, 12 plus 3 15. That's how we're gonna go. Okay, so let's talk about some other things before starting. What about methods of data collection? So mainly you need to tell them how you're going to find out how you're going to measure these, but you can also talk about how you're going to measure the other stuff in the diagram. Okay, so clearly to measure current, we need a an ammeter, clearly, and to measure EMF we need voltage. Okay, the EMF of the power supply. So to measure L and X, okay, to measure L and X, since these are quite long, what instrument do you think we need? If you have longer lengths, you're gonna go for a meter ruler or a ruler, okay. But look at Y. Y is much smaller, right? So you are going to go for a more precise instrument like a micrometer, screw gauge, or vernier calipers or digital calipers. Do you get what I mean? So that's it for methods of data collection. Let's begin then. Okay, let's start. So this, okay, ignore the diagram for now. This is our first part. So L is the independent variable and I is the dependent variable. I talked about this already. You could also say that vary L and measure I. Next, we are going to keep E constant. This is part of this is part of identifying the problem. Then keep X constant and keep A constant, keep Y constant. These are parts of additional details, but as a candidate, like I have the mark scheme in front of me right now, which is why I know where each detail falls exactly, right? But as a candidate, you won't know which line is exactly part of which part, so it's a hit or miss. So why don't you just write all of them down? That's the safest bet, right? Next, methods of data collection. So we're going to measure L and X using a ruler since they were quite long, and we're going to measure Y using calipers or a micrometer. Okay, so that's it for methods of data collection. And the other two, I told you that methods of data collection has 4 marks, so the other 2 marks are actually present in the diagram. one for carrying out a proper circuit, right? Drawing a proper circuit and finding out the EMF of the power supply. So basically, these ends, right? The NC are connected to a power supply. So they're gonna be connected to a power supply. You could also draw a battery, that's fine. And you guys know that the voltmeter has to be connected parallelly, right? And the ammeter has to be connected in series, exactly, right? So this is, you could either draw a power supply like this, honestly. This is present in the in the the syllabus, or this works as well. This is totally fine, but it has to be DC, by the way. So honestly, remember that when you draw the diagram, you have to draw what's present there, what the examiners have given you, but just add something on top of it, an overlay basically, okay? So I just copied it because I can. You guys have to draw it obviously. So after drawing it, connect NC to a DC power supply. Add a switch, please. Connect the ammeter in series and the voltmeter parallel to it. Okay, so I'm gonna dictate the marking points. We need a label diagram of workable experiment, including circuit diagram with power supply connected to NC. We have that. Ammeter in series with power supply. Okay, correct symbol for ammeter and power supply. So yeah, you could go for this battery, or honestly, I think since we want a power supply according to the syllabus, okay, the power supply looks like this. This is a DC power supply, okay. This is much better. And if you draw a wave over here, like if you draw this is an AC power supply, but we need a DC power supply, okay. And we need a circuit diagram with voltmeter correctly positioned to measure E across the power supply. Usually a DC power supply has, you know, readings on it, so we don't need a voltmeter. That's why I chose a battery, honestly, because it might not have a reading across it, okay, on it basically. Okay, so we got 6 marks. We defined the problem, we told them how to collect the data, and we also got 2 additional details when we wrote these 2 points. So basically we got 4 plus 2 6, 6 plus 2 8 marks already out of 15. Now let's go for the other ones, okay. So analysis and extra details, additional details. Out of the 6 marks that are available from additional details, we have already scored 2, so we can score 4 more. However, I'm gonna write all 10 of the points. But listen, even if you write all 10, you aren't going to get 10 marks. You will be capped at 6, okay? But I'm gonna teach you because it's good to know. Also remember, in paper 5 there is no negative marking in the additional details section, so the more you write the better, the safer it is, honestly, okay. So guys, let's begin. In additional details you also have the safety consideration, okay. So let's begin. So in an experiment with electricity, the safety is usually wearing heat resistant gloves or protective gloves. So this is the safety detail. It's kind of lame. The first one, do not touch, or you could say use heat resistant gloves to avoid the hot conductors or the metal bar, okay. Do not touch the metal bar, okay, or use heat resistant gloves to avoid the metal bar. Or we could use a protective resistor. Basically what you could do is you could draw a protective resistor here which actually limits the current, okay. So you could draw it there, it's a protective resistor. What else? You could say that switch off the circuit when it's not in use. As a result, it won't be hot all the time, okay? Then when if you do touch this, it won't be that hot. So basically the middle bar is the scary part over here, okay? So current is actually flowing from here through through this, and through here again. So we are trying to measure the current as we vary this length over here, right? Okay, so we got another additional detail, so we can score 3 more. We can score 3 more. So now I've just told you how to measure L and X and Y. We haven't told them anything about area. Area is something you cannot measure, okay, candidates. To find out area, you have to calculate it. How? Using a micrometer, we're gonna find out the diameter of this rod, this, what's it called, the conductor C, right? the conductor C, and then we're gonna find out area using pi r square or pi d square by 4. Do you get it? Also, when you measure the diameter of a rod or a wire, you're going to place the micrometer at different parts along the length of the wire to get an average value. This is a common point that you'll find all the time, all the time. Okay, this might be in your exam tomorrow. Okay, so basically we're going to say use a micrometer to measure, or you could say calipers. That is also a valid point, to measure the diameter of the conductor, and to find out area it's going to be a is equal to pi d square by 4. Okay, we scored 4 marks. Now we are going to repeat the measurements. Check this point. Repeat the measurements of diameter along the conductor and average. Okay, repeat the measurements of diameter along the conductor, or you could say repeat the measurements of diameter at different points and average. Same point. Okay, 5 marks. Now you gotta ensure something. We have to check that both lengths of L are the same for both conductors. Do you know what this means? Basically, check this. This is a circular object, so it tends to rotate. It could have been like this. Check this, guys. It could have been like this. What if we placed it, uh, you know, in a slanted manner? What if it was like this? What if it was slanted? You get what I mean? As a result, this L, suppose it might have been 10 centimeter, while this L might have been 9.5 centimeter. That won't do. We need to check that both of these lengths are correct. Okay, so before starting the experiment, we need to see if both of them are 10 or both of them are 9.5, like that. So that's another point. Okay, so we need to ensure that both L's, both the lengths L are same. How? By checking the lengths before starting the experiment. Okay, so that's 6 points, guys. We've scored 6 marks. We don't need to write any more, honestly, after this point. However, I'm gonna teach you the other 4 points just for your safety. Okay, by the way, you know about this point, repeating measurements of diameter along the conductor. You could also do that for y. You could measure y over here, here, along the length of the metal bar, and then average, but it would be considered as the same point. You couldn't write it twice to get 2 marks. You'd get 1 mark only. Okay, but it is applicable for the metal rod as well as the conductor. Okay, guys, last 4 points. So remember, I told you that this is a circular object, so it tends to move. So what can we do? To make sure that it's in place, what can we do? We can use an adhesive to prevent the cylindrical conductors from moving. That's a point. Okay. So let's see the points. Keep x constant. Okay. Keep x constant. X is this distance. This one. The orange length. Keep x constant using adhesive to prevent the cylindrical conductors from moving. Okay, keep x constant using adhesives, or we could use blocks to keep them in place on either side of each conductor to prevent the cylindrical conductors from moving. Also, there are other things that we could do, like we could clean the metal bar to ensure good electrical conductivity, or you could use crocodile clips to connect the circuit to the conductors. Like you could use crocodile clips over here to connect the conductor to the circuit to ensure good electrical conductivity. Okay, so that's the same point. Either you could say that you can clean the metal bar, or you can use crocodile clips. Use crocodile clips to connect circuit to conductors slash clean the metal bar to ensure good electrical conductivity. Same point. Okay, next, the last point here. How are you gonna measure x, by the way? because x is actually, this applies for x and L both. X is actually the distance from the center to center. It is very hard to do with your naked eye. Honestly, it's very hard. It's very hard to do with your naked eye. Also, look at L. L is actually measured from the end of the conductor. That's easy to do, but to the center of the metal bar. How? So if you want to talk about L, okay. So to find out L, they have said that we need to measure to the edge. Like basically, you're gonna measure this distance from the end to this edge over here, and then you're gonna add half of this length, y by 2, because you guys know that this length is y, right, the total length. So what about this length, this smaller length over here? The whole thing is y, right? So the half of that length is y by 2. So you could say that to measure L, you could measure to the edge of the middle bar and add y by 2. An alternate point, wait, let me write this in blue. Wait up. To measure L, measure to edge of bar from end of C and add y by 2. Or to measure x, what you could do is you could measure between the conductors and add the diameter. What does that mean? Basically, you could measure this length, like measure up to the ends of the wires, and look at this. Basically, you have one radius over here and one radius over here, right? One radius over here and one radius over here. So r plus r is diameter. So you can measure from one end to the other end and then just add the diameter to measure x. This is also a common point that you'll be facing in many of the question papers. All right. Great, guys, we are done. But you gotta understand that these are extra. Okay, I already got full marks. I wouldn't get extra marks if I wrote these, but you guys won't have access to the mark scheme, so you are supposed to write them. Okay. Now, I didn't write one additional point because one additional point tends to be in the analysis section. Okay, so let's go to the analysis. We are going to tell them how we plot a graph. So let's begin. So uh, we need to rearrange this relationship. We have E by I is equal to 2PL divided by A plus QX divided by Y square. Essentially, we know that L is the independent variable and I is the dependent variable. So we got to rearrange it to y is equal to mx plus c, and I has to be on the left hand side. So let's do this. 1 by I is equal to 2PL divided by AE plus QX by Y square. What next? We need to ensure that L is kept separately. So 1 by I is equal to 2P divided by AE, 2P divided by AE into L plus QX by Y square. Okay, we have a relationship. Y is equal to MX plus C. Great, guys. So we have to plot a graph of 1 by I against L, and the relationship will be valid if a straight line is produced that does not pass through the origin, since we have an intercept, and that's the mark, that's the additional detail. Okay, and I usually write that in the analysis section. Okay, so that's all, and we need to tell them how we're going to find out P and Q, basically by using the gradient and the y-intercept. So let's see how to do this. Okay, so this is the analysis section. This is the mark for analysis. Plot a graph of 1 by I against L. The relationship is valid if a straight line is produced that does not pass through the origin. This section I write it over here, but this is actually an additional detail. Next, to get the last 2 marks, we need to tell them how we get P and Q, since they wanted it in the question. So we know that 2P by A is the gradient, right? So P is actually equal to gradient into AE by 2, right? We also know that Qx divided by EY square is the y-intercept. So Q is actually equal to the y-intercept into EY square divided by x. That is all. Hopefully you guys get it. Or there's an alternate option. No, that's fine. The alternate options are like if you draw different graphs, like L against 1 by I. But this is better. I against 1 by I against L is the better option, honestly. Okay, because I is our dependent variable. Okay, so that's that, guys. Hopefully you understood this part. If you do have other questions though, please feel free to comment below. Okay, so let's move on to oh, by the way, you need to label the diagram. Okay, make sure you label those. You need to label the middle bar, then the conductor. Okay, you need to label the conductor. You need to label the DC power supply, the voltmeter, the ammeter, the protective resistor, if you do draw it, by the way. Okay, so why don't we move on to question number 2 now. I guess we're ready. So the brightness of some stars varies regularly. These stars are called variable stars. Figure 2.1 shows the variation of luminosity with time for a variable star. Great. The student determines the period t and mean luminosity L of the star. The student repeats the process for different variable stars. It is suggested that L and T are related by the equation L is equal to SKT to the power A, where S is the luminosity of the sun and A and K are constants. Okay. So graph is plotted of log L on the y-axis and log T on the x-axis. The first thing I thought of after seeing SKT was T1. Hopefully they win Worlds in 2 days. I'm a League fan, honestly. I love the esports. Faker is the GOAT. Anyway, so the first thing you have to do in question 2 is you need to rearrange the equation. Okay, so clearly we need to introduce log. So log L is equal to log SKT to the power A. So log L is equal to log, basically log T is on the x-axis. So we're going to break it down, right? So log L is equal to log SK plus log T to the power A. Then we bring A down, and A is actually our gradient, yeah? So this is the analysis. Log L is equal to log SK plus log T to the power A, or log L is equal to A log T plus log SK, where A is the gradient and log SK is our y-intercept. Okay, so let's begin. So in this part, in the last video, a lot of you had multiple questions. So I'm going to clarify all of them. So let's begin, like how I did this. Also, for question 2, the only thing that's gonna match when you do the question with me is the, like, are the values on this table. Everything else after this, right? Everything else after this might be different. It might not be the same, okay? But the gradient should be close to my value and the last answer should be close to my value. So let's see. Also, thank you for pointing this out. Someone pointed this out in the last video about the method for log. So I didn't want to talk about it. I wanted to make things simpler for you guys, but like about the significant figures things. So for any table, if log is not included, you will look at the raw number of significant figures, raw number of SF. And when you fill up the table, you could either use the same number of SF or one more, okay? But for log or ln, there's another method. You don't look at the raw number of significant figures for the final answer. You basically look at the raw number of significant figures to find out the number of decimal places. Okay, so the raw number of significant figures in data corresponds to the number of decimal places in the answer. So you can either go for the same number of decimal places or one more. I'll tell you what I mean right now. Okay, so come on, let's do this. So guys, days, t is given in days. So to do this, essentially what you need to do is, since it's log, the decimal places rule applies here. So days is incorporated within the log. Okay, days is incorporated within the log. We don't need to convert it to seconds like typically. This is mainly because if you did convert it to seconds, it's gonna be a really huge value. Okay, and it would be really hard to, it's not something we do. It's not something we do. Like we don't really use a very large value for logarithm here. Yeah, and if you did do that, the answer at the end wouldn't match. So if you do find questions where log is included, log or ln, you do not need to convert the units, and you do not need to take the power into consideration when you input the log. But when you take it out, you need to bring the power back again. I'll tell you what I mean. So let's start. How did I get 1.34 and 1.51? I basically went for just log 22. Try that. So log 22 gives us an answer of 1.1.34242. Okay, so how many significant figures do I use? To solve this, look at the number of significant figures here. We have 2SF here. So this relates to the number of decimal places. So you can either go for 2 decimal places or one more. Since you had 2SF data, you can go for 2 decimal place or 3 decimal place. So you had the option to write this as 1.34 or 1.342. Both would match. Okay, but honestly, I will give you a trick. I'll give you a tip. Go for less number of significant figures. It makes plotting the graph much easier. Okay, so we are gonna go for 1.34 over here. Great. Now let's go to the next one, this one. So that's log 32. Same rule applies. So that's 1.50515. So if you have 2SF data, you can go for 2 decimal place or 3 decimal place. So that's basically 1.51 or 1.5 1.505. These two are accepted. You will see them in the mark scheme. A mixture of significant figures are allowed, but I would honestly suggest you guys to maintain consistency. That's why I'm gonna opt for 1.51. Okay, hopefully you guys get it. Try the other ones please, and they'll match. Great. So let's move on to the next one now, where we're gonna deal with luminosity, log L. So here, let's begin. We do not take the power into consideration. Okay, I'm not doing this, guys. I'm not doing log 2.9 into 10 to the power 30. Please, I'm not doing this. I am just doing log 2.9. Okay, why? Because this is actually log L into 10 power 30 watts. It's not log L watts into 10 power 3. These are different things. Okay, you will always be given the one above, so do not take the power into consideration. Clear? So let's begin. I'm starting with the first one. So that's log 2.9. Log 2.9 gives us a value of 0.462398. So we have 2SF data. 2SF data can be written as 2 decimal places in log or 3 dp. So you could either write this as 0.46 as 2 decimal places or 0.462. Both are fine. Okay, both are fine. That's totally okay. So honestly, here I went with 3SF. Do you know 3 decimal places? Do you know why? To maintain consistency with the last ones. To maintain consistency. I could write both. It's fine. 0.46 or 0.462. But honestly, I went with 0.462 because I wanted consistency. Because in the last one, check this. What if I do this? Log 21. Log 21 is 1.3222. Okay. Now, here's the thing. This is 2SF. 2SF data relates to 2dp or 3dp. Now, I can write 1.32 or 1.322. But here's the thing. Basically, this is too big. I don't want to write this. So I have to write this one, 1.32. And this is 3 significant figures. So I just wanted to maintain consistency. That's why I chose 3 significant figures or 3 decimal places over there. But you guys need to understand something. Even if you guys did write 0.46 here, you would still get full marks. A mixture of significant figures are allowed. You will notice that given in the mark scheme. Okay, I just went for that. So you guys can try all the other ones. In the last two, I just opted for 2 decimal places, but in the other ones, I opted for 3 decimal places to maintain consistency. Okay, great. Now let's go to the last part, which is the uncertainty. So we got an answer of 0.462 over here. How to find out the uncertainty in log? I talked about this in my paper 5.1 video. The rule for log is a bit special. You got to go for log upper bound minus lower bound divided by 2. So the upper bound for this is actually 2.9 plus zero point 0.2, which is 3.1, and the lower bound is actually 2.9 minus zero point 0.2, which is 2.7. So it ranges from 2.7 to 3.1. So the formula for uncertainty is log upper bound 3.1, log upper bound minus log lower bound divided by 2. Log upper bound 3.1 minus log 2.7 divided by 2. So try doing that. Log 3.1 minus log 2.7 divided by 2 gives us an answer of, this is 0.029999, which is basically 0.03. Do you guys get it? So let me do that for another one, see if it matches, like this 16. So log 16 is basically 1.20412. I opted for 2 dp, so I could go for 2 dp or 3 dp, so that's 1.20 as my answer. And the uncertainty is log upper bound 18 minus log lower bound 14 divided by 2. So log 18 minus log 14 divided by 2 gives me an answer of 0.05457. I just opted for 1SF, so that's 0.05. By the way, in A2 Physics Paper 5, you are allowed to go for more than one significant figure in uncertainty. I know it doesn't match with what you learned in AS Physics, but in Paper 5, you are allowed to do that, okay? So that's that, guys. Hopefully your table matches. It's pretty straightforward. Okay, then. Let's move on to the graph. So, in the first part, we need to plot the graph, the line of base fit, and error bars. Okay, we need to plot the points and include the error bars. Then we need to draw the line of base fit and the worst acceptable line. So let's begin. Okay. So 1.34.462. Where is this? Basically, this is 1.35. So this is 1.34, right? So 1.34 and 0.462. 1.34, 0. This is 0.4, 0.45, 0.46. This is 0.46. 462 is basically a bit above that. So 0.462 and 1.34, like this. So I plotted all the points like that, okay? And we end up with something like this. This is what we end up with. Okay? So this is what you'll be getting. I'm zooming into the points to see if you guys get it over here. Okay? Then the next point is 0.69 and 1.51. 1.51 and 0.69. Okay. Then 1.62 and 0.839. 1.62 and 0.839, which is basically 0.84. Then moving on to 1.73 and 0.991. 1.73 and 0.991. Basically 0.99. Then 1.89 and 1.20. 1.89 just before 1.9 and 1.20. And last point is basically 1.99 and 1.32. 1.99 and 1.32. Okay, those are the points. You'll get full marks for this, 1 mark, and then you have to draw the error bars. So the error bars can either be vertical or horizontal depending on the axis. Since L is drawn on the y-axis, the error bars will be vertical over here. Okay, so let's look at the error bars. So 0.462 plus minus 0.3 is basically 0.43 to 49. 0.43 to 49. So this is what I drew over here. It's basically from around 0.43 to 49, but just slightly above 0.432 to 492. Since I gave it to 3 decimal places, it's fine. They don't check it that much, honestly. Then we get an error bar of 0.02, so that's 0.67 to 0.71, 0.67 to 0.71. Okay. Then 0.01, an error bar 0.01, 0.83 to 0.85. Okay. Then again 0.01, which is 0.9 0.8 to 1.0, and then uh, an error bar of 0.05. Okay, 0.05, which is 1.25, 1.15 to 1.25. Wait up, is this wrong? I think I drew a wrong error bar over here. Okay, wait, let me check. The one with 16, right? It's basically log 18 minus log 14 divided by 2. So log 18 minus log 14 by 2. That's 0.5, 0.05457, which is rounded off to 0.05. They did accept 0.06 in the mark scheme, but honestly, it shouldn't be 0.06. It should be 0.05. Okay, so I do have a slight error here. I actually extended it a bit too much, but that's fine. It's okay. It should be 0.05. That's okay. Where's my orange color? Yeah. So it goes up to here and down here. Okay, that's great, guys. So it goes from 1.15 to 1.25. Great. And the last one is 1.32 plus minus 0.04, which is 1.28 to 1.36. 1.28 to 1.36. Perfect. Okay. So after you're done with those, you'll end up with this basically. Now you have to draw the line of best fit. First, draw the line of best fit. I'll tell you why. So this is my line of best fit. Try to make it go through all the points, and if not, make it go through 4 points and pass above one and below the other. That's ideal. So look, it passes through the first point on the left, it passes through second point, third point. Okay, now it passes through the fourth point, kinda. Yeah, it does. Slightly below it, slightly. Yeah, this is fine in what sense? Look at this. It passes through the first point, second point, third point. It passes slightly below the fourth point. It passes through the fifth point and slightly above the last point. This is okay. Something like this should work. You'll get something along the lines of this. Okay, probably. So I hope that's fine with you guys. Now, you need to figure something out. Is your line on the steeper end or on the shallower end? Clearly, my one is on the steeper end because it passes above the last point. That means it's more steeper than it should have been, honestly. So now to draw the line, worst acceptable line. So honestly, you have two options. You can either draw the line, the shallowest line or the steepest line. But I will give you a trick. I'll tell you a tip. Basically, if you have already drawn a slightly steeper line, go for the steepest line. If you have drawn a shallower line, go for the shallowest line. So I've drawn a steeper line, which is why I'm gonna opt for the steepest line. This reduces the uncertainty in the gradient. Okay, so you gotta subtract the gradients to find out the uncertainty, and to draw the steepest line, basically you need to use the upper bound of the last point and the lower bound of the first point. But that's not it. Just joining them won't be enough. You need to check if the line passes through all the error bars. If it doesn't, you need to edit it slightly. Okay, for example, this is how I drew the worst acceptable line. It is passing through the the upper bound of the last point over here, and it is passing through the lower bound of the first point. And I am checking whether the green line passes through all the orange lines. Look, it has passed through all the orange error bars. If it didn't though, you'd need to edit it slightly. So check before drawing with a long scale, the transparent ones, whether it passes through all of them. It's a tricky thing to do. It's a tricky thing to do. What was the alternate option? What was the alternate option? Basically, you could have gone for this, guys. Check this. You could have drawn this as well. Wait up. I messed up big time. Here. Bro. It doesn't let me. Okay, yeah. Okay, so this is one end while this is the other. Yep. So this is the other one. I drew the shallowest line possible. And look, the shallowest line is a perfect example. Check. Like I use the upper bound of the lower, the least point, and the lower bound of the highest point. But what's wrong with it? Check. It doesn't actually pass through all the error bars. Do you get what I mean? So you need to fix this. How exactly? You need to edit it slightly so that it passes through all of them. So I'm going to just move it a bit upward so that it just touches that. Now it's fine. Okay, because it passes through all the error bars now. That's the uh, technique that you have to apply. Anyway, why did I choose the steeper one exactly? Because check this distance. The uncertainty for this yellow line, the shallowest line, is much more than the green line, right? So it's better for me. Or else sometimes the uncertainty might exceed 100%. That happened to us once while we were doing it. While I was doing it with my students. Anyway, that's why I did not opt for the yellow one. I opted for the green one. Okay, and for sure you need to label them, because if you don't, you will lose 1 mark. Okay, next we're gonna find out the gradient with uncertainty. So I drew a triangle. I always try to draw a triangle which I can use for both graphs. Okay, I drew a triangle. So for the line of best fit, the points were 1.96 and 1.3 over here, 1.96 and 1.3, and over here 1.33 and 1.33 and 0.45. So you need to draw a triangle which actually exceeds 50% of the graph. Okay, so I got this value. And then for the worst acceptable line, 1.96 and 1.32 and 1.35 and 0.45. Okay, so I got this value. So to find out the uncertainty, you just need to subtract the gradients. You're going to get a value. I got a value of 0.077. So you're going to get something along the lines of this. Multiple students were asking me in the last video, like whether we're going to get this value exactly. No, there is no accuracy mark, by the way. Here onwards, there's no accuracy mark. Everything else is method marks. Okay, so if you've drawn a wrong graph, but if you've calculated the gradient properly, you will get marks. So the only accuracy mark present here is this table, but afterwards it's just method marks. In some certain papers, there is 1 mark at the end for accuracy, but in recent times, I haven't seen accuracy marks anymore. Okay, so let's move on. I opted for a two significant figure, um, you know, two sig fig uncertainty. Although you shouldn't write down a four significant figure gradient. Honestly, you either go for 2SF or 3SF. That's what the examiners want. So I should have written this as 1 point. Ideally, I should have written it as 1.35 plus minus 0.08. This was much better, and it would have been easy to do, honestly. So it's 1.35 plus minus 0.08. You could also go for this, okay? Although there's no, fixed thing, like the answers below have to be to 2 to 3SF, but you should honestly go for a 3 significant figure gradient with uncertainty, 1SF uncertainty. But this is also fine, but this would have been better. I just realized I don't want to change this now though, because I've done my math with this value, the blue value over here, so it's fine. Okay, anyway, let's move on. But I can still write this over here, I can still write this, it's fine, because I'm going to use the calculator answer anyway, so who cares? Anyway, now we have to determine the y-intercept. This is the common question that you'll face. So you have to do this by not looking at the graph, but rather using y is equal to mx plus c. So I used y equals to mx plus c, and I just used a point that my graph passes through. You can use these points only if your graph passes through them, or you could use these points that you use to find out the gradient. So I did that to find out the y-intercept of the line of best fit, which is minus 1.3566, and I did it again using a point from the worst acceptable line, which I used to find out the gradient over here, 0.45 and 1.35. okay, to get another value of y-intercept. It's going to be negative, by the way. Then I subtracted them to find out the uncertainty. So it's minus 1.35 plus minus 0.13. That's your y-intercept. It should be along these lines, okay? Next, now these two parts were present in the previous paper of paper 5.1. So let's see how to deal with this, okay? Using answers to A, C3 and C4, determine the values of A and K. Include the absolute uncertainties in your values. You need not be concerned with units. Okay. So throw back to the previous part where we write down the equation log L is equal to A log T plus log Sk. So A is the gradient, right? So that is actually equal to this value over here, 1.349, which is rounded off to 1.35 because they want a 2 to 3 SF answer. So that's that, 1.35. You do not need to be concerned with the units. Next, log Sk is your y-intercept. So log Sk is equal to minus 1.35, or this value basically. It will vary. Okay, I used my values, you can use yours, that's fine. So log Sk is equal to minus 1.35. So Sk is equal to 10 to the power minus 1.35. Essentially we did this to get rid of log, we need to do that. Okay, now there's an issue though. There's an issue. Check this. This was the tricky part. So basically what is Sk? It's the y-intercept, something that's on the y-axis. So check out the y-axis. Y-axis is basically your luminosity. So the luminosity, when we inserted the log, do you remember when I found out log L, I actually uh, ignored the 10 to the power 30 while inserting the log. But when we take the log out, we need to introduce that back in. We need to introduce the 10 to the power 30 or else it won't work. That's why, since this is luminosity essentially the y-intercept, when I brought out the log, I needed to introduce this 10 to the power 30. That was the tricky part, okay? Now S is 3.85 into 10 power 26. So if I make K the subject, K is equal to this divided by 3.85 into 10 power 26. I got 117, which I rounded off to 120. Okay, you'll get something like this. Now to find out the uncertainty of these values. Basically, A has an uncertainty of this, the one we found out previously, 0.077 or 0.08, same thing. It's the one from gradient. But for K, it's a more complicated process. We need to find out K again, but using values, using the y-intercept from the worst acceptable line. So I did it again. In what sense? I wrote log Sk is equal to this value over here, minus 1.4754. This is the y-intercept of the worst acceptable line. So K is equal to 10 to the power minus 1.4754 into 10 power 30. I reintroduced it divided by S. I get a value of this. To find out the uncertainty, we need to subtract the value of K from the base fit line and worst acceptable line. I get something like 30. So this is my answer. Okay, that's all. Moving on to the last part, guys. In this section is always present in every paper, where you have to use this again, the main equation, but this time something like L, the value on the x-axis or y-axis won't be given, and you need to find that out. For example, they want us to find out luminosity. I'm going to teach you two ways to do this, okay? So one of them is using the raw equation, the other one is using the log equation. So we know that log L is equal to A log T plus log Sk. So log L is equal to 1.349, that's the value of A, log T. So T is in 5 days, right? Remember, we just input the 5 in, no need to convert it to seconds, plus log Sk. So log Sk is your y-intercept, right? This value. So we don't need to consider the 10 to the power 26 or anything, because we have ignored those while when we input the log here. So that's just minus 1.35. So if you do solve this, you're gonna get an answer of log L is equal to minus 0.4027. Okay, so minus 0.4027. Next, what do we need to do? Check this. Oh, basically I continued it. Oh, this is a continuation. Sorry guys, this is a continuation from this end here. So L is equal to 10 to the power 0.4027, but remember L is luminosity. So when you remove the log, you need to introduce 10 to the power 30. So that's basically 3.9559 into 10 to the power, or this into 10 power 30, which gives us an answer of this. If you round this off to 3SF, it's 3.96 into 10 power 29, or 4.0 into 10 power 29 to 2SF. So this is one way of solving this. What's the other way? Using the raw equation. L is equal to SKT to the power A. Check this. This is the other way. L is equal to SKT to the power A. So L is actually equal to, what's the value of S? 3.85 into 10 power 26 times K. Uh, K is this. K is this value. It's basically around, it's around 120. I'm going to use my raw value, 117 times 117 times T to the power A. T is 5 days. Okay, so we didn't convert days to seconds, so no need to do that. Okay, 5.0 to the power A. What is A? The value of the gradient, right? Which is 1.349. Okay, let's try doing this. 1.349. Okay, so using my calculator, 5 into to the power 1.349 into 117 times 3.85 into 10 power 26. That gives me a value of 3.9496 into 10 to the power 29, which is approximately equal to 3.95 into 10 to the power 29. Okay, so same thing more or less. Okay, it's basically not the exact value because I did not use my calculator answer here. But if I did, I think I'd get something like 4.0 into 10 power 29. Okay, so that's totally fine. If you use your rounded up value or calculator value, it might vary. But yeah, your answer should be around 4.0 into 10 power 29. It might differ slightly. You won't get the same values, but it should be along the lines of this 1.35. Then this approximately should be negative. You should get these values and this. Okay, and you do not need to include the uncertainty. Okay guys, that's it for today's video. Good luck for your exam tomorrow. So I'm gonna link the paper for May-June 2022, paper 5.1 or 5.3 up here. The paper for Feb-March actually, Feb-March 2022, paper 5.2 down here, and the playlist for paper 5 up here. And remember to subscribe to the channel if you like the content. See you guys.